Hello everyone. We'll continue with the permutation chapter. Till now, what we talked about was permutation of the letters and the numbers, where everyone was used only once. We talked about words like number. We talked about words like triangle. Talked about words like equation, where all the letters were distinct. For example, numbers. Each of the letter was written only once. But when we talk about triangle, all the letters appear only once. But if I talk about words like permutation, T is repeated, mathematics, M's are repeated, Allahabad, LA, so many things are repeated. It's small, there are two L's. Then what will happen is what we are supposed to learn today, right? So we are going to do permutation with repetition. Permutation where certain letters or numbers are going to be repeated. I'm not saying that all the letters are allowed to be repeated. That's a different case. You have done that. I'm talking about when in question itself, the word itself has a repeated letter. Then what do we do? First, understand. Supposingly, if I have three different letters, A, B, and C, how many words can be formed using three letters? 3 factorial, that is 6. So, A, B, C, they interchange another word. B, A, C, they interchange another word. C, A, B, they interchange another word, right? Now, instead of this, if I give you A, B, there are three letters. Then technically the answer should have been factorial 3, 6. But it is not. How? Let's see. First, I'm writing it down. Formula will come later. First, common sense. So, one of the word will be AAB. B is in the third position. B is in the second position. B is in the third position. Can you think of any other word that can be formed using two A's and one B? No, these are the only three possibilities. That means the answer should not be factorial 3. The answer should be something else. Now, how do we calculate that? See, what problem here, what happened is this BC interchanging to CB was considered another word. This AC interchanging to CA was considered another word. But here, since the two letters A's are repeated, so when I interchange these two A's, the second day first, the first day later B. Does it give me another one? No, it doesn't even make sense, right? Same here, the first day and the second day. If I interchange them, I don't get another word. Same goes here. The first, second day, and then the first day. It doesn't make sense. So, out of these two possibilities, I've only counted once because the another possibility that I wrote where two A's got the exchange, I'm not counting it as another word. Again, within these two people, within these two people, I'm again counting out of two, only one. And here, out of two, again, I'm counting only one. So what we are doing is the letters, the way the letters are repeated, like the same letters, I'm not counting them again because they're not giving me another word. So instead of 6, we only have 3. Why? Because the two A's that got repeated, two A's can interchange among themselves in factorial two ways. If the two A's would have been A and C, then they would have interchanged in how many ways? Factorial 2, 2. So everyone would have given me one more possibility. Instead of one, they would have given me two answers. So instead of 6, I'm not saying subtract 2. No. Out of two cases, count 1. Again, out of the two repetition, count 1. Again, out of the two repetition, count 1. So in every case where the two same letters are getting exchanged, I'm not counting that. Yes or no?
Yes, ma'am.
So here the total was factorial 3, right? 6. But actually, are we getting 6 words? No, we are getting only 3. So I'm not subtracting 2. I'm dividing by 2. Why is that case? Because in every two word, I'm counting only once. Why am I doing that? Because those are not two different words. Why did I get those two words? Same, because the same letters were arranged. And how many were same? Two. So two letters can, if they would have been different, would have given me factorial to two different answers. But since they are same, those two are same. So out of every two, I'm counting only one. That's why out of 6, I'm only counting 3. So the answer is factorial 3 divided by 2, 6. By 2, 3. Again, if the words would have been, say, A, B, C, D, four different letters, how many words can be formed? How many words can be formed? Online. Out of four letters, how many words can be formed?
4 factorial.
Thank you so much.
24 ways.
Thank you. So 24. Now, if I'm saying that, say, what will happen here? A, B, C, D. So now these B, C, D will arrange among themselves. If I, for example, say that A is going to sit in the first place, but these B, C, D are three different letters, they can arrange among themselves in how many ways? 3 factorial, 6 ways. So there are six words that starts with A. Again, there will be six words that start with B. Again, there will be six words that start with C and then with D. So 24. Now, instead of this, I'm saying that I have A, B. So technically, four letters. So I should have had factorial 24 words. But no, that's not the case. How? This is one possibility. Second possibility. Third possibility. Fourth possibility. Yes or no? These are the four possibilities. So answer is not 24. And again, it is not 24 by 2 also. So that means by 2 is not universal. So how do we do that? Now imagine B sits here. Initially, if A is in the first position, there were 3 factorial 3 words, right? So if B is sitting here, if 3 A's would not have been there and there would have been 3 different letters A, C, D. So how many words would we have got ending with B? Factorial 3, 6. But since those 3 letters in our second case are not different, so that factorial 3, which should have given me 6 different words, is now only giving me one word. So out of those 6 words, I'm only counting one. Again, when B sits in the third place, right? So if there would have been 3 different letters, again factorial 3, 6 words. But instead of 6, I'm taking only one. Why? Because that factorial 3 doesn't give me different answers. So out of again 6 words, I'm counting one. Same goes with the third and the fourth options. So out of every 6, I'm counting one. Out of every 24, I'll count only 4. So basically in this case, what is not counted? The factorial 3 is not counted. So in this case, the actual answer would have been this. But since the letters are repeated, how many? 3 A's. So 3 A's can arrange among themselves in how many ways? Factorial 3 ways, but that I don't want. So out of every that structure, I'm only going to count once. So I'm dividing it by factorial 3. So 24 by 6. 4. That's our answer. So basically what we do is we normally do the factorial, we arrange them, but we divide it by the factorial of the letters that are getting repeated. So if I have, for example, 2 A's, 3 B's, 1 C and 1 D. How many letters in total? 7. So technically I would have written 7 factorial. No selection, only arrangement. But out of these 7, I have repetition. So the number of times when the 2 A's are going to interchange, I'm not going to count that. So first I'm dividing it by that. Again, in that process, whenever the 3 B's are going to interchange, I'm also not going to count that. So that also will get divided. Understood? So basically, total factorial divided by the number of times a letter is repeated. For every repetition, we need to write. Yes or no? Is it clear? So whenever I'm going to write something, I'm writing factorial 4 for something. I'm going to ask, what are those 4 letters? Are there any repetition in those 4 letters? If yes, then divide. If no, then carry on. Understood? Every other concept remains the same. The only thing we need to make sure is this space. Whenever we are writing a factorial, we need to make sure that it is going to have no repetition. Even in case if it has a repetition, we need to divide. Clear? Understood?
Yes,
So now, if I have the word say small, how many words can be formed from the letters?
generally 5 factorial.
In general, 5 factorial, but the 2 L's are divided. So when I'm writing 5 factorial, I'll ask whether in these 5 letters, do we have a repetition? Yes. 2 L's are repeated. I'm going to divide by that. So factorial 5 divided by factorial 2. 60 possibilities.
60 ways.
Yes.
See.
Clear?
Yes.
Yes. Continuing. Second, how many of them will start with a vowel? How many of them will start with a vowel? So, if here we have A, there is only one possibility to make it six. There is only one vowel. How many letters repeated? Four. No more restrictions. So these four letters can be arranged in four factorial ways. Since I've written four factorial, in those four letters, do I have a repetition? Yes, two L's are there. So I'm going to divide it by factorial 2. That makes it 12. Understood?
No. Yes, ma'am.
Third, starts with L, ends with L. Understand? Starts with L. Don't write. I'll give you options. Starts with L, ends with L. Answer, guys. So the first place has to be filled by L. Last place has to be filled by L. How many possibilities? One. Write L. There's no variety of L. Na? Nothing is very fancy and one is very simple L. It's not the case. L. It's basic. So there is only one way to fill the first and the last position. Now there are remaining three letters S, M, A. Those three letters can now be arranged in factorial three ways.
Three
Do I
ways.
have a repetition? No, because S,
No.
M, A are left and in those three there are no repetition. So answer 6.
Six. Six ways.
Yeah.
Yes.
Out of 5 letters, there is one vowel and there is four consonant. In that four consonant, there is a repetition of 12. In how many ways can I have all the consonants together? So whoever we want together, what do? We form a bundle. So if those four consonants are together, I form a bundle. So one vowel and one bundle of consonant makes it two. Two letters can now be arranged in how many ways? 2 factorial. When I said 2 factorial, I counted one vowel, one consonant. So no repetition. Now let's talk about the bundle. The bundle of consonant has four vowels S, M, L, L. So those four letters can be arranged in 4 factorial ways. Now in that 4, there are 2 L. So that will get divided by factorial 2. Understood? So final answer would be 24. So first forming a bundle of whoever I want together, two people, but none of them are repeated. One vowel, one bundle. So factorial 2. Then the bundle can need to be together, but they can be arranged among themselves in factorial 4 ways. Now in that 4, there are 2 L, so I get divided. So whenever we are writing any factorial, we need to question ourselves. What are the letters I'm talking about? Who am I talking about? Is there a repetition in that? And every single time I need to divide. Yes? Online clear?
Yes, ma'am.
Yes, ma'am. Suppose the word is mathematics. In total, there are, I guess, 11 letters. There are 2 M's, 2 A's, 2 T's, 6, and 5 single elements. In how many ways can we form a word? Total repetitions will get divided. That's an inbuilt problem. We need to deal with it. Understood?
Yes, ma'am. Yes, ma'am.
Second, starts with M, ends with M. Starts
One.
with M, ends with M. So the first place and the last place can be filled in one way. Put M there.
Yes,
So
ma'am.
remaining 9 places. So 9 factorial. In those 9, I have 2 A's and 2 T's. Understood?
Yes, ma'am. Yes, ma'am.
Everybody clear?
Yes, ma'am.
In
Yes,
those
ma'am.
11 letters, how many vowels are there? Four vowels, which has two A's, and there are seven consonant, which has two M and two T. In how many ways the vowels are together? Vowels are together. So vowels form a bundle, seven consonant,
Mm.
and this bundle will be forming eight letters. So we write 8 factorial. In those eight, how many are repeated? Wrong, wrong. I counted seven consonant and I counted only one vowel. I counted only one vowel bundle. So there are total eight, one bundle and seven consonants. So 8 factorial. In this 8 factorial, there are only two M repetition and two T repetition. Vowels I'm only considering one. How can two A's repeat? Yes or no? Again, the vowels are together. So I form a bundle of the vowel and the consonants. So seven consonant and this bundle makes it eight. Eight becomes 8 factorial. Within those eight, I'm counting vowels only one. So the two A's are not repeated right now. Now, among the seven consonants, there are two M's and two T's which are repeated. Yes. Now the
Yes.
remaining bundle. So bundle has how many people? Four vowels. So those four vowels can be arranged in four factorial ways.
Yes.
Now, right now in those four vowels, we have two ways. So now it gets divided by two factorial. Understood?
Yes.
Yes, ma'am.
Yes. All the consonants are not together. All consonants are not together. All consonants are not together. Total minus all consonant together. Because I have a problem with all seven being together. I don't have a problem with six. I don't have a problem with five being together or four being together or three being together or two or all of them different if it's possible. I only have a problem with one scenario, which is when all seven are together. So what do we do? Total. Total is 11 factorial
7.
divided by 2 divided by 2 divided by 2. Now I don't want the consonants to be together. So we form a bundle of the together. So four vowels and this bundle are a total of 5 factorial. Now in those 5 we have counted four vowels. So four vowels that means two A's. So that is the repetition. Yes. Now we counted the consonant as one bundle. So within the bundle, they can arrange among themselves in 7 factorial ways. Now, as I wrote 7 factorial, those 7 has two M's and two T's. Clear?
Yes.
Yes, ma'am.
Clear? Suppose the word is combination. Eleven letters, repeated, two O's, two I's, two N's. Anything else? Same only. Sorry. New word. Drinking. 8 letters, two I's, two N's, four single, hmm? Or eight, how many vowels? Two vowels, both are A's, I's, and six consonant, which has two N's. First, how many words can be formed?
In general, 8 factorial.
But those eight has two I's and two N's. Yes.
Yes.
Second, vowels are together. Vowels are together means the two I's are together, right? Vowels are together means the two I's are together. So those vowel or the I's form a bundle. So six consonant and this bundle makes it seven. So 7 means 7 factorial. In that 7, I have two n's. So factorial 2. Now comes the bundle. Bundle has two i's. Do we need to interchange them? No, two i's cannot be interchanged. What will it give me? Nothing. So let it be. Yes, no.
Yes.
Any problem?
No.
No, ma'am.
Clear? Clear? Okay. Let's start the worksheet. Did till 16, 17 to 21. 17. How many different words can be formed with the letters of the word Mississippi? So Mississippi has how many letters? 11 letters, which has 4 S, 4 I, and 2 P, 1 M. So without restriction, just form a word. So total divided by the repetitions. Any doubt?
No.
No, ma'am.
The 4 I's come together. So these 4 I's form a bundle. So 4, 5, 6, 7, 8 people. So 8 factorial. In those 8, there are 4 S and 2 P. 4 I's do not come together. A minus B, total minus together. In A, we talked about total. B, we talked about being together. C, we don't want them to be together. So total minus together. Apple minus Y. Clear? Online clear?
Yes. Yes.
Yes, ma'am.
Next, Allahabad. Allahabad has how many letters? 9, which has 4 A's, 2 L's. Okay. So vowels occupy even position. How many vowels? 4 vowels, which are 4 A's, right? Now 9 letters has 4 vowels and 4 consonant. All the 4 vowels are A's. So they have to set in the even positions. 9 letters. So even positions are second, fourth, sixth, and eighth. There are 4 even positions: second, fourth, sixth, and eighth. And there are 4 vowels. So in general, it's usually factorial 4. No selection, only arrangement. But here there is no arrangement also. Because all the 4 letters are what? A. So how many ways are there to make those 4 A's sit at second, fourth, sixth, and eighth place? Only one. So 4 A's can sit in the even places in one way. There are remaining 5 consonants, 5 places, odd places. Those 5 places can be filled in 5 factorial ways. But in those 5, there are 2 L. So divided by factorial. Is it understood?
Yes. Yes.
Everybody clear? If the vowels would
Yes,
have been
ma'am.
something else, if I would have had 3 A and 1 I, then I would have written 4 factorial because 4 even position and 4 letters. But in that, there would have been 3 repetition. So divided by factorial 3. Right now, 4 positions. So salo 4 factorial. But out of those 4, all 4 are same. So there is no arrangement. So divided by factorial 4, it's 1. There is only one way to write 4 A's in those 4 positions. 1. Just write it. Then the remaining are the 5 consonants and the 5 odd places. So 5 factorial. In those 5, I have 2 L, 2 repetition. So 5 factorial. I don't want them to be together. I want them to be second, fourth, sixth, third, basically kind of alternate. Both L do not come together. Both L do not come together. So basically it will be total minus together. Total will be factorial 9, factorial 4, factorial 9 letters, 4 A's and 2 L's. Minus together. Which one will be together? The 2 L's will be together. So 4A, 1 bundle, 5 and 3 single. 8 people, 8 factorial. In those 8, there are 4 A's. Yes. Right? Then the bundle. The bundle has 2 L's. So there is no need to arrange them. Whenever the bundle has all same letters, then what's the point of arranging them? Clear?
Yes.
Any doubt?
No.
19. In how many ways can the letters of the word permutations be arranged? So there are in total 12 letters in which there are two T's, or there are 12 letters which has all five vowels and seven consonant. The seven consonant has two T's, right? So the word starts with P, ends with S. The word starts with P, ends with S. So first letter one way P sits, last letter one S sits. Remaining 10 places, 10 letters. So how many ways? 10 factorial. But in those 10, there are two T's. So divided by 2 factorial. Yes or no?
Yes, ma'am.
Vowels are all together. So the vowels form a bundle. So 7 consonant and this bundle makes it 8 people. So factorial 8. In those 8, there are two T's. So 5 by factorial 2. Now comes the bundle. Bundle has 5 vowels. No, they are not same. So 5 factorial. Is there a repetition in those 5? No. Understood.
Yes.
Ma'am.
Everybody clear?
Ma'am.
Yes, ma'am.
20. In how many ways can 4 red, 3 yellow, and 2 green discs be arranged in a row if the discs of the same color are indistinguishable? That means they are identical. There are 4 red identical balls. There are 3 yellow identical discs. There are 2 identical green discs. So in total, there are 9 discs. 9 discs can be arranged in factorial 9 ways. But out of that, 4 are identical, then 3 are identical, then 2 are identical. Yes?
Yes.
Okay, 21. What will happen with 21? Can you all tell me? Yeah, I want a number, 7-digit number that should be greater than 10 lakh. There are total 7, so 6 zeros. Huh. So, can you tell me how to do 21, guys?
Mm, 7 factorial.
Yeah, no, wrong. Only 7 factorial.
No, ma'am. I'm 7 factorial divided by 3 factorial into 2 factorial.
That's it.
Ma'am, then after that we have to find the possibility with 6 digits since a 7-digit number can't start with a 0.
Yeah.
Then we should minus the difference and we'll get 360.
Perfect. So basically, I want the number to be more than 10 lakh. So the first place can be filled by 1, it can be filled by 2, it can be filled by 4, right? But it can't be filled by 0. It can't be filled by 0, right? So I have problem with only 1. So there are 2 ways to do this. I have 1, 0, 3 twos and 2 fours, right? 7 digits. So in total, if I don't do any restriction, so 7 digits, 7 factorial, there are 3 twos and 2 fours. But I have a problem with one case. What is the one case? When 0 is sitting in the first place. So if 0 sits in the first place, one way to fill the first position. Remaining 6 places, so 6 factorial. In those 6, there are 3 twos and 2 fours. So total minus the cases in which 0 starts with. Or what we can do is case 1 starts with 1. I can't do together because there is a repetition. Case 2 starts with 2. Case 3 starts with 4. There is no 4. So if the number starts with 1, first case is filled, 1 way. How many letters left? 6. So 6 is 6 factorial. So if 1 is gone, I am left with these letters, these digits. Yes or no? So that's why 6 factorial. Now in those 6, there are 3 twos and 2 fours. Yes or no?
Yes.
Or it starts with 2. So if the first place is filled by 2, there is one way to do that. What are the remaining digits left? 1, 0, 2 twos and 2 fours. So 6 place digits can be arranged in 6 factorial ways. Now in these 6 possibilities, what are the repetition? There are 2 2s and there are 2 4s. Because one of the two got used in the first place. Yes or no? Now starts with 4. If the first place has to be filled by 4, there is one way to do that. Now there are 6 digits left. There are 6 digits left. 1, 0, 2, 2, 2. 1 second. So the first place got filled by 4. Now there are remaining 6. So 6 factorial in which there is only one repetition of 3 2s. 4 is not even getting repeated anymore. And then you can add them. Understood? So both the ways are true, whichever way you want to do it. Any problem?
No more.
No, ma'am.
Clear? Clear?
Yes.
Exercise 7.4. Start. थोड़ा सा यूज है खाली इसका. Exercise 7.4. Question number 1. In how many ways can 3 white, 4 red, and 1 blue marble be arranged in a row if marbles of the same color are indistinguishable? We did a similar question right now. 8 factorial divided by factorial 3 factorial 4. Yes?
Yes, mom.
Answer 280.
280 ways.
Second, how many different signals can be transmitted by posting 3 red, 4 yellow, and 2 blue flags on a pole, assuming that in transmitting a signal, all the 9 flags are to be used and flags of the same color are indistinguishable? Same. Factorial 9 divided by factorial 3 factorial 4 factorial 2. Answer.
Ma'am, answer is
1260.
1260.
Third, find the number of arrangements that can be made out of the following words. Root, 4 letters, 2 repetitions. So 12. Second, banana. So 6 letters, 2 N's, 3 A's. Answer.
60.
60. Third, apple. So factorial 5. There are 2 P's. Answer. 60.
60.
Pineapple. How many letters? 9.
30.
Out of that, there are 3 P's, 2 A's, 2 E's.
2
That's it.
is
30 to
Answer.
40. 30 to 40.
30,240.
40.
Institute. Again, 9 letters, 3 T's, 2 I's. Same answer.
30 to 40.
Civilization. How many letters? There are 12 letters,
12.
4 I's. That's it.
Yes, ma'am.
Answer.
Yes, ma'am.
In exam, don't do that. Leave it. It's not possible. 1995840. 7. Commerce. 8 letters, 2 M's, 2 C's, 2 E's. Answer. 504.
50.
Does it
504.
match?
Yes, ma'am.
Yes, ma'am.
All of you?
Yes, ma'am.
So that's it for permutations. In our next session, we'll start with combination. Combination is pretty small.